Greetings to everyone. Today we are going to study about 3D printing. Let us get into the topic. So, synopsis. These are the topics, which is the headings of the topics which I am going to cover in this presentation. Let's get into that. Okay, 3D printing. What is 3D printing? Do you have any ideas about what is 3D printing? I do not have any idea. So let's get into it and we see what is 3D printing. Okay, 3D printing. 3D printing or additive manufacturing, which is both ways same. It is the construction of a three-dimensional object. So it is basically a construction of three-dimensional object from a CAD or a computer-aided softwares. So from a softwares, drawing softwares or design softwares like AutoCAD, Solidus, something which produce 3D structures. From that design, we can produce a three-dimensional object, which is the 3D printing. Okay, let's we understood about the basic here. Let us see about the term 3D printing. Why it is called actually 3D printing? So the 3D printing process in which a material is deposited. So 3D printing is nothing but particle is deposited, solidified, or joined by the control of a computer. By the control of a computer with powders or inkjet, with the powders, plastics, such as liquid molecules, powder, and everything together fused to form a material, which is typically a layer by layer process. So this results in a 3D object. Okay, let's get into the next topic. Okay, why is 3D printing? As we know that we have lots of the process to produce prototypes. So in which why we have specifically needed the need of 3D printing. So let's see why the need is necessary. So in 3D printing, the process is the fastest process. So it is the most fastest process to produce prototypes. For example, if you try to produce a process by sand molding or a prototype by sand molding or cast molding or machining, it will take maybe days or even several hours or days to produce a single prototype. A prototype, a prototype is just an example of the product, not the exact product. If the prototype itself is taking so much time, how would we manage the errors, and how will we find the fact that errors and small things and the dimension accuracy, surface finish, everything? It's just a prototype. We have to identify the errors and we have to rectify it very soon, so that we can produce more products. In that way it will affect our cost, production rate, everything. So if a prototype takes so much long, the total process collapse. So in order to that, we must produce prototypes very fast. In that case, there comes 3D printing. So the 3D printing is its time efficient, as I mentioned here, because it produces hundreds and thousands of prototypes within an hour. So how much efficiency it is? So it saves much times, lot of power, and it also does not consider a lot of manpower. So in other processes like sand molding or die casting or rolling, or some other process, cold rolling process, hot rolling, all the process, cold working, hot working process, it will require manpower. But in this process, manpower is not required. The only thing is just a design of the prototype to be produced. From the design, we can produce n number of prototypes within ease and very frequently within the involvement of less manpower. So that is the need of 3D printing here. Okay, let's get into that. Next topic. Okay, so as we now heard about what is 3D printing and why we need 3D printing, let us discuss about the principle and working of 3D printing. Okay, a typical 3D printing is nothing but the inkjet printer. So inkjet printer, you know that we produce a color printing or a Xerox copy. So that is inkjet printers. So from that inkjet printer, what is the different from 3D printing is instead of producing ink, instead of producing ink, ink as a solution or material to produce the color which we required, or a Xerox copy black and white ink. We produce some plastic modules. See, plastic or powders. The printer deposit layers of molten plastic or powder, and fuses them together. So from with that help we can produce 3D printing. Okay, so let us discuss the principle. So it builds a 3D model one layer at a time. 3D model one layer at a time. So if we take this is one object, so here from the start it's one layer, so next layer, third layer, fourth layer. So if by this step by step process produce one by one layer up and above to produce a 3D object which we required. So that is the process. So same area, by creating same area, so same size same area, so same palm hand size area from one layer, it like a building up one layer to produce a whole object which is a 3D object. So this process is called as a fused deposition method. Okay, next let's get into the next topic. Okay, as we know about what is 3D printing and why we need it, and what are the principle and the operations behind it, let us see what are the parts are there. So the parts of 3D printing are listed below. Let us read it. The first one is D resolution layer thickness. So as we know, we have to maintain the same area, and the thickness should be maintained properly so that we might get a proper fine object without no ruptures or maybe cracks, something like that, no defects. That's the main role of that G resolution layer thickness. And we have build area, so the area which is specified, so that is build area. Filament thickness, so the light and the filament which produce that thickness. Hot end nozzle from which the ink or the plastic molecules which enters. Extruder, you know that which we pushes upside to produce object, so that extruder. Cooling fan in order to avoid from overheating, because we produce plastic molecules, not ink, so that will read more process. And heated bed, so in order to maintain the heat we need heated bed, and a print bed of surface which will print the surface one by one layer, so that is and LC display which will display how it's going on, and what are the processes taking on that, and multiple extruders. So these are the parts of 3D printing. Okay, let's get into the next. Yeah, here is the typical device. It's not the exact inside part, but it's a typical device how it will look. So here the 3D print which we specified, and this is the cooling fan, and this is hot end, and a filament which I showed, and extruder which will pull the object, and the print display, so that the display which tells us that how much the object is going and what is it going, something like that. Okay, now we discuss about 3D printing and what is 3D printing and how it's all going. So let us see about what are the types of 3D printing. So the types of 3D printing are stereolithography, selective laser sintering, fused deposition modeling, digital light process, multi-jet fusion, polyjet, direct metal laser sintering, electron beam melting. So from the words of this topic you might get an idea of what are these. So selective laser sintering, maybe it uses laser. Fused deposition modeling, which will maybe uses a fusion method to produce deposition modeling. Digital light process, which is a digital light which may produce. It's just an idea. You can get what it is, from the topic of its polyjet, direct metal laser beam, electron beam, by passing electron beams like proton, electron, what is not proton, just electron beam melting. Okay, let's get into the topic. What is stereolithography? Okay, stereolithography is the 3D printing process. So it produces a high definition of smoothness, a level of details, complex structures, everything can be done here. So what is this? It's basically the qualities of finishes. Yeah, it is widely used in the medical industry, and common application include anatomical models and microfluids. So it is basically used in medical fields. So why, you might think why a prototype is needed in medical fields, but in order to study about the inside of human organs, we will not take and cut a human body and examine it. So in order to that, we produce these kind of prototypes which will resemble the actual organs of our body. So it is very stereolithographic 3D printing is very useful in that process. Okay, next, selective laser sintering. Selective laser sintering is a nylon based powder into solid plastic. So previously it is just a ink, now it is specifically a nylon powder which is produced to form the 3D object which we required. So this is durable because it is a nylon, so it's a thermoplastic metal. So it is highly durable and wear resistance, heat resistance, and as everything in comparison to SL. Yeah, SL. So the previously we showed about SL, which is something. So in order to, if we compared with SL, it is more stronger than SL, and it does not require structures. So the whole build platform can be utilized to nest multiple parts into a single build. So it unlike SL requires lots of parts. So we know, but it does not require lots of parts. It just requires some parts and less cost than the SL, so which is very much useful there. So many SL products, SLS products are used to prototype design that will one day be injection molded. Interesting. So they are saying that many SLS parts, so the SLS parts which are of the prototype are used to produce inject molders. So inject modelers are nothing but which produce the plastic or particle molecules which will produce prototype. So that's kind of vice versa. Okay, next, get into the next type. So next type is multi-jet fusion. So multi-jet fusion is similar to SLS, but rather than using a laser to sinter the powder, so instead of using laser, it uses a injector array to apply fusing agents to the bed of nylon powder. Okay, instead of using laser to point the nylon powder, it uses a inject array, so which will fuses together by the composition of chemical composition. Okay, then by heating the bed, so that will form to fuse to each other and form the 3D object which will reach. So that is this. But it is very beneficial because it is low cost. Okay, next topic, polyjet. Polyjet is another plastic 3D printing process as we discussed, but there's a twist. It can be fabricated parts with multiple properties such as colors and materials. Interesting. The other things are not that light. It can be fabricated parts with multiple properties such as colors and materials. So the previously talked about SL, SLS, MJF, which cannot be done by colors or materials, but here polyjet which can be introduced by colors and materials. So we can decide what color we want to produce the prototype and what material we want to produce the prototype, etc. Okay, designers can leverage technology for prototype, elastometric or over molded process. Okay, this can help you iterate and validate your design faster and save you money. So as far as we know that SLS is faster than SL, and MJF is faster than SLS. And now it's the polyjet. So the polyjet is faster and consumes less money than the other types which we discussed. Okay, next, digital light processing. Okay, digital light processing is similar to SLA. It's the first one which we talked about. Requires liquid resin using light. So unlike other topics which require a nylon powder or other materials, it requires a fluid liquid resin. So as we know about resin is a form of a liquid which comes from plant or even from some decayed animal body something, and especially from plants. So that resin is using light, so they inject that resin and use lights to amplify it and solidify it to form a 3D object. Yeah, that's what is. So in order to produce a volume runs of plastic parts, Unlike other process which forms a plastic, it's formed from a resin of plants. So I think it will be more beneficial and economical and environmental friendly. That's the main point in that, because it's environmental friendly. It will decay because plants are decaying, but plastics are not decaying. So I think this is a more efficient product, and economically it's more efficient, and the cost is also very much less. I think every other company should use this process. Next, fusion deposition modeling. So, fusion deposition modeling is a common test of 3D printing for plastic work. So, it is the basic common process in which we design the product in a computer, and we design the product in the computer, and we form a 3D printing object. So, it is cost effective and quick method for production physical methods. Uh, yeah, physical method, but it is also lacking some surface because it cannot produce rough surfaces, and the strength is very much poor here. So most of them we not do. It's just for some light-weighted object, or the object which does not require strength or something like that. For example, for example. Yeah, some chips which we use, which will not need not to be in a stronger manner, but we need to see that prototypes. So something like that. Okay, now we are getting into the deepest and the main part of 3D printing, which is the application. So i I specified, and I not declared it, but I have categorized the topic into mainly three top application to three topics. First is medicine, and the second one is, as we see, aerospace and defense, and the third one is visualization. So these three are the main applications where 3D printing used. Let us get into the medicine. So medicine, here already we seen. So as I previously encoded that, I have told that 3D printing is useful in producing organs of human parts. So human parts organs, parts of human organs. So here in which parts of human organs. So let's just discuss about what are the medicine applied we get. So arms and legs. As we discussed, some of them will be lost. Their legs are born with crippled, with one hand, one leg, or even one eye or something like that. So for that people, the these prototypes will be very much helpful in that, to produce the legs which they can use, and to produce in the robotic string which will connect them into our body, so that they can walk again. So people who have been crippled, you know and it also can be produced muscles from Cornell University. They have designed to produce muscles, which is very interesting, isn't it? The 3D printing have been used to produce artificial tissues, cells, and skins. Interesting, isn't it? It's not just an mass object, like which object which can be held by our, like heart, lungs, or hand limbs, which can also produce some smaller micro organic, like um, skin skin cells, and artificial tissues, which is very very minute. So it shows that how accuracy it is and how range it can be produced. Extra. Apart from replacement body parts, 3D is increasingly being used for medical education and training. As I previously mentioned, they are, apart from replacing body parts, they are also used for producing, used as training for newbies in medical field, so that they will not risk lives. So they must be risk on lifing to save someone. So if you try to teach them, they should not risk somebody's someone's organs or something. So in order to that, it is very much helpful in learning some of the object which we cannot be seen, or which will cause them to damage. No, it's just basic learning. Next, aerospace and defense. So in aerospace and defense, in order to produce an aerospace or a aircraft or a rocket or a something defense air, yeah, missile or everything, it costs millions. So if you want to produce such kind of million products, you should be accurate about that. Otherwise it will fall off the sky, or if it's flying from the space, it will fall into the under space. We have heard so many news that the plane crashes, or it malfunctions, or when it launches it sinks into the ocean, something like this. It's a very disappointment, and loss of cost, loss of money, lots of parts, lots of work, everything have been waste. So in order to prevent those, you have to use the prototypes in aerospace and defense. So think of that. If you use a prototype, if the design is wrong, we can rectify it, which will not cost much. It's just a printing machine which can be used regularly, and the material which is used are maybe not that much cost. So we can produce a prototype within a hour or two to see, and we can examine it and rectify the errors which we acquired, and we can simulate the condition, and we can check how much it can survive, which condition it can survive, and all that things. So it is very useful in that. So that's why it's usually useful in airspace and defense. Okay, next, the final use of application of 3D printing: visualization. Visualization is what I explained in all the above object. We can visualize how the object can be look. So if we take this glass, the prototype, if it is weird, we can see that how it look, how it fit my eyes, how it fit my nose, how it is going here. Everything we can see it only if we take and put it here. We cannot just see it in a showroom or a showcase which is say okay it will be fit to our eyes. It's not like that. So this 3D printing prototype helps us to visualize object, and we can able to bring the object to our life. So it is very useful in such kind of things. So that's what it is. So it yeah, it is very useful because instead of going to reach in the product into the market, we can examine it before in hand, and we can test it in, and we can rectify it, so we can so that the product will be sold very nice, or we will not lose our customers which are basically come for our quality and finishing, or maybe yeah, surface finish and without errors. So it is very useful in that. The main use of prototypes is to visualizing how an object can be looked. So that's the main fact in that. So with that, I am closing this topic. I just want to recall what we have seen here. So first we started with what is 3D printing, and we slightly moved on from what is 3D printing and why we need a 3D printing. So as we know, 3D printing it's very much easy and time efficient. So 3D printing it is used. Next we talked about 3D printing definitions, principle and operations of 3D printing, and principle and operation of 3D printing, and parts of 3D printing, and we saw the diagram which is very nice. It's not an exact diagram, but it's an prototype or assumption diagram. Prototype, yeah, it's interesting, and then we saw about what are the types of 3D printing, and we have discussed about what are the types. There are several types: stereolithography, SL, SLS, MJF, jet, polyjet, and lots of things. And then we start about application. There are three main topics in application, which is aerospace and defense, medicine, and visualization. Visualization is the main and first and foremost application of 3D printing. So herewith I finish my presentation. Hope you guys enjoyed my presentation. If you like this video, please leave a like in the comment, and subscribe to our SAS YouTube channel. Thank you.